And just lay the page protector one, just, push it to the side for now. Start with this, but let me make it bigger. It's really big. All right, let's start with that as a review problem. Remember what we reviewed yesterday about this. Kennedy, when you first multiplied, what did you get? 24/9. Anybody else get 24/9 as like your first step? Yeah, that's what you should have gotten. You only multiply this whole number times the numerator, and that's what we get. We carry over the denominator. It stays the same. And then we're going to number bond that and get what? 9 ninths twice, which would be 18 ninths. Okay. And what's the leftover piece? 6 ninths. Okay. Question? Is that what you got? Except this turns into a what? 2. This is 2 6 ninths. And that is an outstanding 4th grade answer. What could your 5th grade answer be? Think, what is the largest number I can divide both of these by? Okay. You can divide both of these by 3, so you would get 2 2/3. So 4th grade answer, 5th grade answer, both of them are correct. Okay. This is just what we call simplified or reduced. So you may see those words in like iReady and things like that. That's what they're talking about. Okay, I'm going to leave the fraction problems. I do want us to practice one of these. Let's go with Okay. How many 3s can we get out of 8? It's easy sometimes just, I can just get 1. Be careful because if you can get more, take as many out as you can because that's going to make the rest of the problem flow easy. Okay. How many 3s? 2. Okay. 3 times 2 is 6. Bring down that 7. All right, that's, fact family. The bell comes, the light comes on, the bell rings. How many 3s can we get out of 27, everybody?
9.
That's one of our 9s. 3 times 9 is 27. Bring down the 4. What's the most 3s we can get out of that? Just 1. And another fact family jumps out at us. Yeah.
4.
Okay. We can get 4 3s. That's the most we can get out, and that is 12. So there's no remainder. We go to check. 3 times 4 is 12. 3 times 1 is 3, plus 1 more is 4. 3 times 9 is 27. That's 6, 7, 8. And there's our dividends right there. Okay. All right. Go ahead and clear this off. And we're going to jump into today. Just like yesterday had a lot of parts to it. Yesterday we had place value discs. We had, what else? What was on our template that we put in our new whiteboard?
It was
Not a tape diagram, but a,
number 1.
well, we did have number line.
Oh,
Oh, you know what? I'm thinking back 2 days. It was 2 days ago we had the area model, wasn't it? Okay. So number line, we have place value discs. So we are seeing decimals in just lots of different ways. Okay? And all that is trying to do is get you comfortable with them. Okay? Today I can model the equivalence. So we're going to be trying to make something equal when you see that word equivalence. Tenths and hundredths. All right, so today, we've been right here at tenths. There's my little eyes. We've been right here at tenths, and that's where we've stayed. We're going to start kind of venturing into that next place over. Now, really and truly, those are the 2. I put 3 up here, and these, it goes on forever, just like this direction does. It goes that way forever. We're not going to get here. You might see a number occasionally that has a thousandths place, but really in 4th grade, we're going to concentrate on these 2 places, and that's all. So today we're going to start seeing how this works when you have another place. It is slightly different than some things we're used to, so we want to understand how that all works. We are going to see the area model and use that. We're going to see some pictures of the place value discs. We're not going to pull them out again and start working with them. I think we can handle what we're doing without them today. All right, so we're kind of jumping through a lot of different parts today too. All right. Let me see where I want us to get started. It helps when you're on the correct page. There we go. Are these Miss Elizabeth's? I'm going to borrow. Some of my books don't want to stay open, but what's weird is I don't even know where it went. On the floor? Oh, wow. Pretty powerful guy there. I got more I can give her back if I can. Oh, you just, it's kind of like the thing on the ornament of a Christmas tree. If it pops out, you just squeeze it and pop it back in. Okay. I used to have this giant paper clip that I use and I can't find it. I'll have to find it. All right. some of these slides got a little wonky and part of it's hard to read, so I may just draw some of this on this plain screen right here. Alright, the other day we saw this. 3, 4, 5, 6, 7, 8, 9. And that's why you have a template, because if we had to draw this for every single problem we ever did, it would take a while, okay? And so we shaded on our area model. This was an area model, and we shaded on it to show different tints. Remember, because how many pieces is it cut into? How many pieces is it cut into? Okay, let's wake up. Okay. Now, I did tell you that the denominator we're going to see most of the time is either going to be a 10 or, do you remember the other one?
100.
Or it's going to be 100. Okay. What would I need to do to that to make it have 100 pieces instead of just 10? What would be the easiest thing to do? Now, I could microscopically draw 10 lines in between each of those, but what's another way to do it? Yeah. Horizontal lines, and this is something we're familiar with saying. Let me draw another one beside it. I'm trying to keep them about the same size. I know they're not going to be perfect when they're drawn. 2, 3, 4, 6, 7, 8, 9. That gives us 10 pieces, but if I go like this with 9 lines to create 10 pieces this way, 2, 3, 9. About running out of space, didn't I? Okay. So, do you see why we have a template? Because to do that every single time to make sure it's accurate, you know, we've got all of our 100 pieces here. And we will have a template that we'll tear out in a little bit and put into our other whiteboard. Okay. So, if I did some shading and I shaded this, okay. And I did some shading and I shaded this. Okay. I just want you to do some noticing. I just want you to do some observing. There's lots of things. You might be sitting there going, all she did was shade. But there are lots of things that you could tell me about those two area models right now when you're looking at them together. So I want you to look at them for a few minutes. What do you observe? What do you notice? It's not really a wrong answer here. Okay, Reagan, what's one thing you notice?
They are both the same. Because there's 10 pieces in the 100 and then there's just one whole.
Okay. Do you mean like there's the same amount is shaded? Okay. It's just cut a little differently maybe? Okay. So you're noticing that maybe one column over here is shaded and one column over here is shaded? Do y'all see that? That it's the same amount that's shaded even though it's cut differently? Okay. I'm trying to think of an example. If I had what was the best? Now, if I handed this to Caleb and he had a 4th, and I handed this to Ishmael and he had 2/8, I'm handing them the same amount. They're just cut differently. You see what we're saying? If I laid these on top of each other, they would be exactly the same amount of pizza. Okay? It's equal. But this pizza got cut more times. And so it's the same amount of pizza. It's just cut differently. Same idea here. It's the same amount, just cut a little differently. What do you observe?
Like what you said with the 4th and the 8th.
Okay.
The 4th is like the pizza you get from Subway. and the 8 would be like the pizza you would get from a regular pizza place.
Okay. What's different about those two restaurants you're thinking of? Like, how do they do their pizza?
Like, one of them's bigger and the other ones are smaller. Like Pizza Pro, you know how they're smaller?
Okay. So, but like the pizza might be the same size pizza. They just cut it differently, don't they? Yeah. And sometimes you have to cut something differently because you got to share it more times, or there's more people to share it with, that type of thing. Okay. So our first observation, same amount, but it is cut differently. Anything else that you notice? Everybody's brain on. Check the switch. Low battery power. Anybody?
Yep, low battery power. Yeah.
She's getting the sun in her. I think she's got an advantage back there. She gets more sun energy by that window. Yeah, but today it's coming through. All right. What do you want to add? Okay. Same amount, more cuts in it. Anything else?
When you shave both of them, there's 90 pieces left in the 100.
Okay.
And there's only 9 pieces left in the 10, but it's the same amount.
Okay. All right, so let me show you something. So we've got this to look at, but sometimes we need to take that and put it into numbers so that we, understand it both ways. So if we were to write this as a fraction, this one, what would we have? Yeah. We would just simply have 1/10. This is, I'm not asking you anything that's difficult, okay? If I were to ask what the fraction, seriously, we didn't hear art today. What is the fraction to go here, Faith?
100.
Well, it's 100ths. We're going to have to, that's a mouthful, 100ths. But how many 100ths? How many is this? Just count them. How many hundredths are in one column? And that's something we probably want to get familiar with. Okay? How many? There are 10. All right, so a second ago, we were talking about pizza. We're talking about, what do you notice? I kept hearing it's the same amount, it's just cut different. It's the same, it's just cut a little different. Okay, so when I hear the word same in math, it's math, so I think math sometimes. I think of equal. So could we say that this is equal to this? Are they the same when it comes to the numbers? I mean, if they're going to be the same as pictures, as models, shouldn't they be the same as numbers too? Okay, so let's do an experiment here. If we put that, and then we're going to see, is it? Okay, hold on, I get it, but hold on. What I want you to do now is I want you to observe this. Now, long ago, in a galaxy far, long ago, we talked about fractions that were equal, and we know ways to check that. We know different methods to get from one place to another. Do you see any of that going on with these numbers? And it doesn't matter if this is big. Who cares how big it is? We can handle this. Okay? So I want you to, what do you notice? Notice something?
If you do 10 times 10, it's 100, and 100 times 1 is 100.
Okay. Well, if you do 10 times 10, it's 100. And if I do 1 times 10, it's 10. If I do 1 times 100, it's 100. Okay. So well, hold on. I don't know if I'm saying that right or if I'm hearing you right.
You can do the heart method.
Okay. Oh, whoa. I was going straight across. You're doing. I got you. Okay. Let's check with the heart method. So if we go around, 10 times 10 is 100, and 100. I'm not drawing through it, so I can erase it. 100 times 1 is 100. So, yeah, right away with the heart method, we know it's equal. Oh, let's just erase it. I was trying so hard not to have to erase that.
Low battery.
Yeah. Hey, but this is the thing. We worked hard and all week, and so we kind of expect our battery to be a little low right now. But there's something about it gets about Thursday afternoon, Thursday evening, and the battery it's Friday, and I have enough energy to get me through. So, you can do power through. Power through. Alright. Hold on. Bailey just proved to us with the heart method these are equal. What is another way? Come on, use your numbers. You can do this a lot of different ways. Yeah. Steal it and hide it. So if we did that, we would multiply both of these. I like it when I change the color. We would multiply both of these by 10 and both of these by 100. And over here we would get, oh goodness, we would get 100 1,000s. Did y'all get that there's 100, we're multiplying by 10, we just add a 0. Over here we would get 100 1,000s.
We're in thousands now.
Okay, so once again, with steal it and hide it, we have proved these are equal. Yeah, I need somebody to tell me at least one more method because I'm going to be honest here. We're probably not going to use, hold on, I want you to hear this. We're probably not going to use steal it and hide it and heart method very much with decimals. There's another way that with these particular numbers, it just seems to be quicker, easier, and all that. Martin, what are you saying? Reasoning? Okay. But really we need more like solid proof right now. So I want a number way. That's what I'm looking for right now. Keep that thought because I'm going to come back to that last. Okay? Remember me saying a lot in fractions? How do we get from here to here? Everybody needs to be telling me how I get from there to there. What do you think, Kennedy? Remember me? You gotta say it really loud. Number line? Well, we could show these on a number line, and we could show that, that would help. But I'm trying really hard for us not to have to use something else to look at. I want us to use just the numbers. For just a second, anyway. What do you think? Say one more. Okay, again, don't want to, we're going to pull some of that stuff out in a little bit. Y'all are getting ahead of me. Need to let y'all come teach. All right, what are you thinking? Okay, now y'all are just doing this. What was on that list? Hold on. Good ideas, but look at the numbers. How do you get from here to here? I know. How do you get, yes. And what do you multiply by? Go ahead. Okay. We got 10 and 100. Listen, this is gonna help you with lots of problems that we're gonna have in a few more days. You multiply by 10. How do I get from 1 to 10? I multiply by 10. How did I get from 10 to 100? Multiply. I don't know what that weird little line is, but let's times 10. Okay? If I multiply 10 times 10, I'm going to get 100. So I also got to multiply whatever the numerator is by 10. Okay. Multiplying by 10 is not that difficult, is it? We're adding a 0. Multiplying by 10 is going to happen a lot with decimals. So I want us to get comfortable with that. Okay. So could you do heart method like to just check if these are equal? Yeah, we just proved that. And steal it and hide it. And you could reason. And you could probably think about your benchmarks and all those things. But I was hoping somebody would see this so we could bring this up pretty quick because we're going to be doing this a lot. Okay? All right. So, let's do this. What happens if I go here? It goes away. Okay. Let's go here. Okay. See, but what's going to happen when I touch the board? This whole setup, not good, but anyway. We'll see. We'll try. Well, you don't really need that so much. All right, we've got 2 templates here. I just didn't, it's going to take me a while to draw it every single time. I didn't want to draw it every single time. If I have, I'll tell you what, this would be a perfect time to kind of pause and let you get your template out because we're going to start needing to do it. I don't want to do it by myself every time. I want you helping me. So, the page number, I'm not sure because I saw it in my book. But go to your workbook, and this is in lesson 5. And the templates are usually at the back.
28. Page 27.
Okay, so let's hold on a second. Double check here. All right, and it says it at the top. You don't have to guess. It says lesson 5 template. So it is page 27, 28. It's both of those. So tear it out, and let's see. Let's cover up the number line page today. Okay. No, I'm going to take that back. Let's cover up the area models so that we don't get confused when I say area models. We go to this one by accident. Cover up the one that has the 5 boxes. Okay? Let me give you a minute to do that. Leave the number line page showing. You're going to cover up that side right there. If you get it wrong, it's not a big deal. Yeah, I'm covering up the other area model that's already in there. We're replacing it for it. Okay, got it. All right. Now, I don't know how this board is going to act when I touch it with a pen because I've got it in a different mode right now. All right, so what we're going to do is we're going to shade in 3/10. And if we're talking about tenths, we're talking about this one right here. Okay. So we're going to shade in. You can try to draw these. I know it might take longer. Okay. We're going to shade in 3 of these. You know what's easiest to do? If you will just outline 3 of them. Don't color them all by themselves. Grab 3 of them together. Boom. Shade it all together. And I know it may help to do it that way with the marker, the size marker you have. Okay, and underneath, let's see where you've got room. You may have to do this up above. You've got room underneath. Do it. I'm going to do it down here because I have more room. If you have more room on top, that's fine. Let's write the fraction for this. What is the fraction for this? Yeah. This is 3/10. Okay. All right. Let's shade the same amount over here. Let's find 3 columns. I know they're cut the other way too, but 3 columns would still be this much right here. All right, what's the fraction that's equal to that second box? Faith, what do you think? How many little bitty boxes are in here total?
100.
Yeah, we don't have to count them. We know that's 100. But Faith, what's the fraction to go here? How many of these hundredths did we just shade in? Say it real loud. 30. Okay. 30 hundredths. Is 3/10 and 30 hundredths equal to each other? Can you see it in the area model? Yes. But what with multiplication, what would it be? What would I need to write right in here? Yeah. Times 10. Okay. needed you to write this as decimal form because our directions do mention that. What is 3/10 as a decimal? What does it look like? Ishmael, what does it look like? 0.3. Okay. What does 31/100 look like as a decimal? What do you think? What do you think?
0.30.
It is. Okay.
I was thinking of saying 30.0.
All right, yeah, be careful about that because that's way different. All right, y'all look at me for a second. Use your eyes. This is important. And this is probably, y'all been this whole time. This is easy. And I'm glad. Probably one of the trickiest things in 4th grade decimals is this right here. That some people will still call that 3/10 or get confused as to what its name is. Look at me for a second because I'm going to say this a lot. And I want you to get used to what I'm saying. You see how that we put a digit in the hundredths place? If you have a decimal number and it has a digit out to the hundredths place, you can't call it tenths. Okay? We now have a digit in this place. So it has turned into hundredths. Now it might be equal to something that's in the tenths. But it's hundredths now. That's how you would say that. Okay, we've got 0.30 hundredths or 0.30 hundredths. This is 0.310 or 0.3. Okay, you'll see that a whole lot. Let's keep going. How does it? All right. You can see they have the same thing right there.
Let's go.
Okay. All right, I want you to see this. Go ahead and just lay your marker down for a second. It says, let's show the equivalent fractions using division. They started with hundredths this time and then went to tenths. Sometimes you're going to have to go the opposite direction. If you're going from larger digits to smaller digits, divide. So if you divide by 10, if you divide 10 by 10, you get
10.
If I divide 10 by 10,
No, 1.
1. We're dividing. If I divide 100 by 10, I'm going to get 10. Okay. So we're going to move on from. Okay. We're going to follow these directions and do a little bit of this for practice. Now it says use multiplication, so we don't need our template right now. We may come back to it in just a minute. So we just need our regular whiteboard, okay? Because we're using multiplication here. We're not drawing an area model. We're not drawing a tape diagram. We're not drawing anything. Use multiplication to find how many hundredths are in 3/10. So we know our first number, 3/10. So write that on your board. Okay. Now we've already used this one. They're giving us a lot of the same problem here at the beginning just to get the understanding of what to do. Use multiplication to find how many hundredths. Well, look, I know it's a word form right there, but we already know our next denominator. So if you get a problem like that, that's how you would set it up to figure it out. All right, so we've already talked about this. How do we get from here to here? What did they do? Yeah. They multiplied by 10. So 3 times 10 and 10 times 10 is going to give us what? What's our final fraction, Brandon?
3,100.
3,100. So 3/10 is equal to 3,100. So see how fractions and decimals are working together here? Okay, so let's do a few others. First one I want you to do on your board is convert just means to change. So we're going to change 7/10. That's what you're going to start with. So write 7/10 on your board. 7/10 to 70/100. So they've already told us the answer. Yeah, pretty much. But what's missing is what you multiplied by. So how did you get from 7/10 to 70/100? Have we already said this out loud? Yep, a bunch of times. We're saying it a bunch of times so we can get it stuck up here. Go ahead and write your second fraction, guys. But how did we get here?
Yeah. We did times 10.
We multiplied by 10.
This is easy.
Yeah, it is. Just getting practice with it. Just figuring out how hundredths work today. Okay. Now, I want you to see this. So I don't think we have a template for this on this. No. Put the top on your marker and lay it down for just a second. We may make one of these in a minute, but we don't need it yet. Okay. So here's a tape diagram. We're pulling out a lot of different models today. We've seen the area model, but look at this tape diagram. And I want you to look closely at it. The other day we used a tape diagram when we were working with tenths. And this tape diagram is still cut into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So it's still showing tenths. But you can see as well as I can that they've added something a little different to it. What do you think they're trying to show us on this tape diagram? Look at it carefully. What have they done? I mean, let's just describe what you're seeing. What do you see?
They cut it into tenths, and then one of the boxes have shaded, and then it's cut into tenths.
Okay. I like how you describe that. So this whole thing is cut into tenths. And then they've shaded, 2 of those. But then this box, they've shaded half of it, but it got cut, that one box got cut into what? 10 more pieces. So those really aren't tenths anymore. Each one of these little guys is a hundredth. Because if I did that to every single box, I got 10 of these boxes. If I to every single box, I would have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I would have 100 of those itty bitty pieces. Okay. Now, guys, just like it took me a while to draw that area model and put all the lines in it, okay, if you're asked to do a tape diagram like this is kind of a shortcut way to do it. I don't have to cut every single piece. I really just need to cut the one that's not all the way filled up so that I can show how many pieces are filled up. Okay? So what would this number be? What number are they showing? It is a decimal number because these are tenths. What do you think? That's what we got to be able to figure out. Plus we want to also be able to know the number first and draw one like this. Okay? What do you think? Okay, you're putting your decimal in the wrong place. Okay, because this is one whole right here. These aren't whole numbers. So think one more time. You've got some of your digits right, just not what you just said is not in the right order. Okay. All of this is smaller than 1. All of this is behind the decimal. Guys, stay with me because you're going to wind up having to do some of this on your own. Try it again. What? No. I don't want you to change the digits that you had because you had the right digits. Things were not in the, you weren't telling me everything in the right order. Yeah. 0 point what? All right, we don't say it as fifths, but 0.25. Is that okay? All right, now I'm going to write that. A lot of times I ask, do you agree with this? Blah, blah, blah. Oh, I can't do that. This is correct. Now, look at this and look at this. These go together. This is showing this. I want you to kind of observe how that works. Can anybody explain how that works? Yeah, go ahead.
So, in this one, you have to two because there's two blocks shaded in there, and then there's 5 little ones shaded, and that's where you have to 5.
Okay. What is each of these boxes, guys? This size box right here. What are each of these? Everybody. No. What size is this? What? These are tenths. These are tenths. Right? Everybody? Yes. Oh, yes. Oh, Monday. Yes. So easy. Those are tenths. Oh, yes. Okay, don't forget that all of a sudden because it looks different now. These are all tenths. How many of those tenths are shaded in?
2.
2 are shaded in completely. Ta-da! That 2 is in the tenths place. What size piece are these little itty bitties? We just said it a minute ago. Because if I cut all of these boxes into those itty bitties, I'd have how many? I'd have 100. So those little itty bitties are hundredths. How many hundredths are shaded in? And the 5 is in the hundredths place. Okay? All right. So we've got 2 tenths shaded in. We've got 5 hundredths shaded in. See how that works? Now, how do I read that? Ishmael had all the right parts, but you just said it a little differently. You said almost correctly, but said it a little differently. So let's see how this. Do you want to give it a try? It's very simple. Some people want to look at that and go 25 tenths, but you can't have 25 tenths. That's too big to fit in the tenths column. So if your number goes out to the hundredths place, you've got to change what you say. This is 25 hundredths. Okay? So it's not that it's difficult, it's just we got to get that. That if my number here goes out to the hundredths place, I say hundredths instead of tenths. Okay? If I had another digit there, let's say there was a 3.
Yeah.
Then it would be what? It would be 253 thousandths because I had gone out to the thousandths place. And so on and so on down. But we don't have to worry about we've just got to look at 2 of these places in 4th grade. The rest will come later. Because right now we're just getting very comfortable with decimals. And then when you get to 5th grade, you start using them a lot more. Okay? Because by then you get more how they work. Okay? All right. But I think that's probably one of the biggest places where 4th graders make mistakes with decimals, where it gets hard for them, is remembering that this is hundredths and not tenths, and remembering how to read those. Yeah.
When I first saw decimals and the way you said it, I thought it was like 4, but then as soon as you showed us, it was like 7.
Yeah, it's just once I hear it and kind of get it, it does make sense. Okie doke. We're moving on. So, okay. Now, just a second ago, they showed us 25 hundredths in a tape diagram, right? Now, what does 25 hundredths look like in an area model? Now, hold on, because I want to show you kind of a shortcut way. So I'm just going to have you watch it first. What is this cut into? Say it loud. This is tenths. Yeah, but this is 25 hundredths. Oh no, what do we do? What would you do? If you've got this and you've got to show it, but this is all you have, and there is more than one way to do it, but what would be maybe the first thing you think of? Yeah. I could cut it this way also, and now if I cut it this way with 9 lines, oh goodness, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I cut it, and then what could I do?
Yeah.
Keep going.
Shade.
Shade? Yeah, I need to count and then shade it. But you know what? I don't have to go 1, 2, 3. Come on. Count by 10s. Let's get to 20 fast. This is 20.
And then just shade that 5.
And then 5. Okay. Okay. Oh, nobody said it was hard. You're right. But I'm trying to get to show you an even easier way. Okay? So, here we go. That's 25 hundredths now. Okay? Guys, we want to get to the point where we know, I know, that is cut in 10 pieces, and I know that every one of those 10 pieces could be cut into, could be cut into 10 pieces to make 100. If I know that, and see, we've had a hundreds chart in front of us since probably pre-K, right? We kind of are familiar with this 100 boxes. So let's just, I know that this is 20. Okay? Right? I just shaded in 2/10, but 2/10 is also 20 hundredths. I need 5 more hundredths. So I'm just going to cut one of these guys into 10 pieces. And I'm going to shade 5 of those. So see how I did that? I know all of them can be cut into 10 pieces. So 10, 20, and if I'm not showing all 10 of them, let me cut just that one column so I can show you exactly how many, I'm talking about. This is 25 hundredths, which is equal to 0.25. Look at the diagram and look at the number. Let me write this over here. 0.25. Would you look at there? We've got 2 of our tenths colored in. 2 in the tenths column. And we've got 5 hundredths right there. Our 5 in our hundredths column. Okay? So, hoping that helps as we go along. We're going to practice some of this stuff later on. I know you're excited about that. Okay, on your template, let's get rid of. You have, y'all stand up for just a second. I'll give you a minute. I need you to move for 1 minute. That wasn't very good, but yeah. You can walk, you can jog in place. All of this is in place by your desk. You can march. You can do jumping jacks as long as you're not whacking somebody, but you should be far enough away from it. All right, ready? Go. Red hand's got to get back to the floor. And it's a long time. Got to be moving. Got to be moving. Got to be up, though. I want you out of your seat for just a minute.
All right, minutes over.
No, that red hand's got to get all the way back to the floor.
Wait, the red hand has to get all the way forward. Oh my gosh, it flew over the Ishmael.
Get a lot done in a minute.
What are you doing? Please turn the other way and do that.
What are you doing? Do you need to do that to you?
No, she turned around.
Remember that thing about treating others like you want to be treated? So whatever you do to someone else, you must be okay with it coming back to you.
All right, time for stuff. Oh, time isn't
Keep moving. Y'all even moving like snails. I'm giving y'all a stretch break and y'all
We
on.
need battery power, which means a bed.
Okay, let's go.
Yeah.
Alright, you can stop, have a seat. Okay. We need some blood flow to that brain. Alright, now I want you to sit up, take a talk. Use those muscles in your back to hold you up.
Ow, my
Okay. Using those muscles, we're making the blood flow more. Alright, so this gives us two hundreds boxes side by side. We've got two that are on top of each other right here. We'll just use those two. So in the first one, I want you to shade 52 hundredths. Okay, go ahead and do that in the first hundredths box that you have. You've got 2 hundredths boxes on there. Grab 5 of those at once. And on your second hundredths box, I'm going to do 35 hundredths. If you outline them, it just makes it easier to see exactly what you were trying to shade in. Okay, this is what we're going to do next. We're going to create 2 different kinds of models on our regular. Leave this, because we're going to use these same 2 fractions, but we're going to now take this and cut your board in half. Either way, but we're going to make 2 different things on our whiteboard, our regular whiteboard. Okay. Okay. For the 52 hundredths, let's see which one would be easier to do. Let's create a box like that, which we're going to cut into tenths. So it's an area model also. And I know we're drawing this one. Make sure you draw 9 lines to cut it. Let's see one. Oops.
How does this feel so hard?
Hmm.
Why does this feel so hard?
Guys, count your lines. Make sure you got 9 that are cutting it, because I was 1 short. Sometimes you just got to take one of those spaces and cut it in half. Okay? Okay. Now, we're going to try that shortcut way. So if I was shading this in to match 52 hundredths, how many columns do I need to shade in? How many total columns, like how many columns do I need to shade in completely? 5. Okay, we're not drawing the horizontal lines, guys. We're just drawing. Okay, if you drew the lines like this, erase them. Start over. Okay? I need you to listen and stop. This is what you need right here. No more than that. Okay? what we're trying to do is shade this without having to draw every single one of those horizontal lines. That's what we're practicing. So how many, if we want 52 hundredths with 52 hundredths, if we want to do 52 hundredths and we have a tenths area model, how many columns are we going to shade completely? Yeah. 5 of them. So trace 5 of them and shade those in. Right. What are we going to do with the very next column? Cut it into 10 pieces. So take just that very next column and cut it into 10 pieces. So it kind of looks like I have this one in the middle that's just trying to do something a little different. And I'm going to shade 2 of those. And that's a little simpler than having to draw every single horizontal line. Because it just gets messy sometimes when we have to shade or to draw that many lines. Okay, with this one, we're not doing the same thing, so don't draw the same thing for this guy. This one, we're going to try the tape diagram. Okay? So on your whiteboard in that other open space, we're going to draw a tape diagram. How many pieces do you think we're going to cut that into? 10. If you need to turn your board for this one the long way, that's fine. All right, everybody's with me. We're still going to be able to show 35 hundredths here. All right, think about the tape diagram that looked a little different that we saw a few minutes ago. What are we going to shade? 3 whole boxes. What are we going to do to the very next box? We're going to cut just that very next box into 10 pieces. Ooh, that's going to be tough, isn't it? It is on my board. Goodness. And this is why we would rather do just one box like this and not all of them. I can't even hardly count those. You know, my lines are, they're bumping together. Yeah. But how many of those itty bitties are we going to shade in? 5 of those, because 5 is in the hundredths place on 35. So carefully try to color those in. Alright, you can kind of see it. Yeah. It leaves what out?
Whenever you draw the area on it, it's easy to make
I like how you turned yours. That might make it easier to see. Mason, instead of doing lines like this that went the same direction, you turned his this way, right here. You can do that as long as it's cut into 10 equal pieces. It doesn't matter which direction you've got. You know, and so since all the other lines are like this, it was easier to see his cut this way. Okay. Maybe all of you did that.
I did.
See someone else, you did it too? Okay. Alright. You can put the top on your marker and lay it down for a second. I told you we weren't going to get out place value discs today. We're not. But I do want you to see what they look like. If you have a place value disc that is worth a hundredth, it's going to be 0.01. Okay. This is where we probably make the more mistakes because of the zeros. Okay, guys, put your eyes up here. Some people accidentally in 4th grade will write this and think they've written a hundredth. That 1 is in the tenths place. You can't have hundredths if you haven't gone out to the hundredths place. See how that 0 pushes you out to the hundredths place? Yeah. If you're going to have a single digit like that out in the hundredths place, it's got to be pushed out to the hundredths place. So that's what that 0 is doing. Okie doke. We are nearing the end here. I don't like doing my slides this way anymore. Okay. I do. But when I leave them on the side, I also know what's coming and I can jump to the ones I want to jump to and skip the ones these are going to skip. Alright, this is just showing you what I was telling you before, that this is in the hundredths place, or sorry, the tenths place. That 6 is in the hundredths place. Okay. Alright, so this, no, stop moving little discs. Okay, this is what we need to practice. This is what gets us in 4th grade. We have 5 100ths. Okay, you're going to use your just regular old whiteboard. I want you to write 5 100ths in unit form. Now, what do we mean when we say unit form? What shows up in unit form? Yep.
There's always as the numerator.
No. I know what you're talking about. You're talking about unit fractions. This is unit form. It's a way to write numbers. What?
And you can only put 1 on top with the number.
No, that's unit fractions. Unit form, guys, has words with it. How would you write 5 100ths, 5 hundredths in unit form? Let your ear help you. Okay, I want you to write it. In a second, I'm going to ask you to hold it up. Show me. 5 hundredths. Unit form is a combination of numbers and words together. You say that. Maybe that'll help somebody remember. Because we've seen unit form a lot this year. Okay, show me what you got. If you have nothing. Remember all these all these decimal words end with that th. Okay. You don't want to get them confused with these right here. Okay. A lot of you are on the right track. Just make it easier for yourself. It's this right here. You don't have to write out the word 5. We probably practice unit form the least of all the forms. Okay. All right, you can leave that. Now, how does this get written as decimal form? That's the one I want to get to. How would you write that as a decimal? Okay, just give it a try. This is 5 hundredths. Don't show it yet. You're showing it to me. You're showing it to everybody that might not be finished yet. Okay. Something. Now this is usually, don't show your board. I usually get one of two things. Either this or this. Okay, show me what you got. Okay. Oh, and I also do get this one. Just that. Okay, you can put your boards down. All right, our correct one is this right here. Okay, several of you had this at first. Okay. All right, so this is 50 hundredths. This is 5 hundredths. That 0 is pushing the 5 to the hundredths place. Okay, so be careful on that. Can I please take this out of this mode? It's driving me crazy. What did I do? There it is. Wow, that's from yesterday. Let's go into the lesson for today. Okay. All right, let's try one more. 25 hundredths. All right, write it as in unit form first. 25 hundredths. And again, you're showing the rest of the room right there. All right, show me what you got. All right, some of you are showing me a number that's like humongous because you're writing this word right here. Hundreds and hundredths. Totally different. Okay. So what you needed was 25 hundredths. Okay, need that ending right there. All right, write it as a decimal. Write it as a decimal. 25 hundredths. What would that look like? Lay your boards down, please. 25. Brandon, make sure you're writing this. 25 hundredths as a decimal. This is making us think just a little bit more, isn't it? Yeah. It's easy to get, tricked on this. All right, show me what you got. When you look at that, you've got to have a 2, you've got to have a 5. Okay, got to have a decimal somewhere. Okay. All right, a little bit of a mixture, so let's look and see what that is. That's going to be 0.25. Okay. Having those 2 digits pushes you out to the hundredth place. Okay. We'll get it. If this is confusing, this is just one little part of all the decimal stuff we're doing, so we're going to get it. All right, I think we are, yeah. So today has just been a lot of practice with a lot of different things. Okay, go ahead and clear your board. And we will practice this some more because I can tell this very last thing we need more than any of what we've done. We'll practice a little more of this in our work. Go ahead and take the time to clean both of these off and put both of them away. Snap this one into your binder. We'll keep working with this stuff.